Welcome back. Now we're going to take a little bit of a look at a really important set of ideas called templates. Templates are useful in a couple of ways. In one way, a template is a tool for you to build more powerful classes. And that's going to be great. So that we always like to have more power, right? But then the other way they're useful is that they are used to build a series of incredibly useful tools in C++ and other languages. So we're going to take a look at this idea. First, we'll build our own template and understand how they work. And then we'll take just a little sneaky look at how powerful they are in some of the standard libraries in more modern C++ development. So let's get into it, shall we? All right, let's do it. So first I've got, let's look at my files here. Let's do this template demo, vim template demo. And you can see in here first I have a class called addInts. Now just for the sake of brevity, I've done it sort of in the Java style because it doesn't do much. It has 3 integer attributes, and then its constructor takes these 3 attributes. Remember, this is a shortcut, so if I don't give it any parameters, it simply will replace x with 1, y with 2, z with 3. Okay, and then we'll just copy those things to the local data members. Okay, nothing shocking. We have a getSum, which also is not shocking because, well, you can add integers, and if you did add integers, you would get an integer. So the getSum returns x plus y plus z, and we're done. Silly class, probably way overkill, but that's okay. Stay with me. I'm making a point. We could also have a class. Now, the great thing about addInts is it's great for adding ints, but what if I want to add floats? Well, it can't do that. That's not what it does. Now, could I have modified it in some way so it could? Yeah, maybe I would have something, but if we want to have this class add floats without significant changes, we can't really do it. We could make a new class, right? Add floats. And when you compare these two classes, they're almost identical, right? In fact, they are identical except, in fact, I think I may have come close to copying and pasting them because all I did was everywhere I said int, I said float, right? So the add floats takes 3 floats. And we'll make them 1.1, 2.2, 3.3, just because that's more floaty. Assign the values, and again, we can add them. Notice that the getSum is identical because adding an int plus an int plus an int makes sense. Adding a float plus a float plus a float makes sense too, right? And that is because the plus sign the plus operator was overloaded for these things, right? Remember, we talked about that. Review that if you need to. So we can have an addInts and an add floats, but it seems crazy that the code is almost identical. The only thing that's different in this case is the data types. And wouldn't it be nice if we had a way that we could build a class that wasn't quite so fussy about data types, so that maybe as long as we knew that we were doing things that were legal, we could use any data type. That would be really interesting, and that's exactly what a template is about. Let me show you this next one. Okay, I have an add things. Now, it's not quite a class, it's a template. And the template takes a parameter in these angle braces. And this is not really an ordinary parameter. This parameter is a type name that I'm going to call T. And so what this takes is a data type. Now, the data types for now are going to be primitive data types, but it turns out we can even do classes, and that's incredibly powerful. So let's take a look at this a little bit and see what's happening. Type name T. All right, that's good. So T is going to be int or float or maybe something else, right? And then what we're going to do is, let's jump on down to main so you can see what's happening, right? addInts. Okay, we create an addInts, we get it sum. Add floats, we create an add floats instance, we get it sum. Add things. Now look at how we use add things. when we create add things, we have to put in a data type. We can put in int, we can put in float, and oh my goodness, could we put in string? Turns out we can. We'll see. All right, so this is pretty neat, isn't it? Yes, it is pretty neat. Let's see what's happening. So type name T. So T is going to be for now int or float. And then we're going to have our 3 data members. But what type are they? Well, they're type T, whatever that is. Traditionally, you use a capital T for this. Okay. And now we'll have our constructor, which has type TX, type TY, type TZ. Now, you might be asking, how in the world could this thing compile if it doesn't know the data types? And you'd be right, it can't. And that's why this is called a template, not a class. So what happens is when you try to create an instance of this thing, what it's going to do is delay the class definition until you create an instance of it. So that's pretty cool. So it will do its very best to create a new class based on the type you indicate. And there could be more than one. You'll see some examples of that. But we can create an instance of this thing even if we don't know what its key data type is. And that turns out to be incredibly useful. But let's see. Okay, so the interesting thing here is the code still did not change. So the code is the same thing that it's always been. Now you look at it in main and it's fascinating, right? Add ints, add floats, add things int works exactly the same as add ints. Now I can't presume what data members are going to be in this thing, right? Now I have to have, I can't have a null parameter constructor of this, for example, which is fine. I guess I could, but somehow I'd have to fill in the data. So, okay, as long as I call it an int, I can feed it 3 ints. As I call it add things float, I can throw in 3 floats. Here's the crazy thing. Return x plus y plus z. Does that work on ints? Yes, it does, because the plus sign is overloaded for 2 ints. Does it work on floats? Yes, it does, because the plus sign is overloaded on 2 floats. What about that complex class we created in an earlier video? Well, we overloaded the plus sign for that, so this will work. What about strings? Well, in C++, strings have the plus sign overloaded as well. It becomes concatenation. So could we do this, which we never intended? Standard string. This is fun. Well, let's try it, shall we? Okay, we'll try it. I'm right there with you. Okay, so G++ template demo dot CPP. It compiled a dot out. And look, it did all that stuff. Now it didn't put spaces between there, and maybe you want that, but that's okay. All it's really saying is that any kind of a class that supports, that overloads the plus operator in this case, can be used in this template. And that's incredibly powerful. How powerful? Okay. So some of you learned Python before. Maybe you've done Java, or maybe you've done some other language, and you're like, you know, C++ arrays are really limiting. You know, when I do arrays in Python, I can put, you know, lots of different stuff in them, and I can change the size dynamically, and I can add elements to the end, and so on. And we can't do any of that in C++. Well, right. Because the array in Python wasn't really an array, it was something closer to this. Or if you've done Java, you might know something about what's called array lists or vectors. And you're like, well, those are way more powerful than arrays. Right, because they are using some of this magic. Oh, yeah. Or maybe you know something that you've heard of this idea, an associative array or a dictionary, sometimes it's called, where you can have an array that uses a string index rather than a numeric index. Well, C++ is dumb. It doesn't have that. It does have that. It has all these things. And so templates turn out to be useful because we can use them to represent two really, really important higher level ideas. And as C++ was originally developed, it didn't have these in them. It came a little bit later, but it's available in all. And then people would start to develop these templates for two main uses. One was to make fancier containers, stuff like array lists and vectors and dictionaries, which we're calling maps. So that is one usage. The other usage is to do algorithms, things like sorting and searching. What? Yeah, let me show you. If we go back to the modules here in our class, I've given you some links here under this unit you should really take a look at. Originally, we had this thing called STL, the Standard Template Library, that was kind of the set of objects that everybody used. But as it became more and more standard, it actually just kind of got built into C++ itself. So be sure to take a look at these things. You'll see a bunch of these like containers. So there's a container for a fancier array, and vector. DQ is double-ended Q. And we'll do some of these. We'll do a vector, right, real soon. And a map and a multi-map and some other cool things. Now, I'm not going to go through all of these things. I will show you a couple of them. And you'll see that once you kind of understand how these work, they turn out to be super, super useful and powerful. And so a lot of times the thing that you think of as an array in another language is actually something closer to this. So that's one thing. The other thing that you'll see, which can be very, very useful as well, is this idea of, where are we? Algorithm templates. And you'll want to do a little bit of quality time looking through the documentation. But some of these algorithms are really neat. Here's some of my favorites. Sort sorts a bunch of elements, and it does actually a quite efficient sort. Oh, that's interesting. Shuffle. These are all things that you might have been complaining about C++ not having, but here they are. It's just that you can't really use them until you understand the templates a little bit. And I don't know, I'll look around. I don't know if I have a sort example just in front of me, but I'll at least show you a couple of these. So let's take a look at a couple of the container examples. One of the first ones, and one that I love, is it has a different name in every language, it seems. Some languages call it associative array, some call it a dictionary, some call it a map, but it's always the same thing. And that is, okay, we're used to arrays having numeric indices, and numeric indices make a lot of sense in most cases, right? There's some nice things about having an integer index. The most important is that, well, that maps to the pointer arithmetic that we're using to keep track of where these things are in memory. That's probably the main reason we use integer indices, because that integer becomes the offset for the pointer math. Once we know where element 0 is, we can find all the others. But sometimes that's problematic. Like, tell me the name of state number 7. Right? Well, it doesn't really, you know, your next question will be, well, which one is number 7? What are we going to do? Alphabetical order they came into the union? What does it mean to be state number 7? But if I told you, tell me the capital of the state whose name is Indiana, you could probably figure it out, because in a normal year, we'd be sitting literally half mile from the Capitol building. Okay, so you could figure that out, right? And so sometimes it's useful to use other things besides integers as an index for a collection of things. And so C++ has this really neat library called the map. So include map, and then you can make this map. Well, this one is interesting because it takes two two data types. And often you would use both strings. Usually I use a string as the key, and then you could use something else, even your own class, for the value. Okay, and so we can do a string, state cap. Okay, great. So then I could say state cap Indiana gets Indianapolis, state cap Florida gets Tallahassee. And somehow magically what's happening is we're able to access these data members, or these elements of this collection, through a string index rather than a numeric index. Of course, there's an obvious question. How does it then know how to put it in memory? And that turns out to be one of the really interesting challenges of computer science. I think you'll get into it in a data structure and algorithms class, I believe, where you talk about what's called a hashing function. So what happens is that somehow you have to figure out a good, fast way to get a unique integer index out of a string. And that is one of the massive problems of algorithms and data structures. We're not going to do that today, but I hope you get a chance to play around with that. But hashing functions are really, really important and interesting. They're used not only for this, but also for cryptography. So it's kind of neat. All right, so that's pretty useful. So this is a nice little tool that I could use, and I don't have to know how to build my own template. I can just use this existing one. That's super neat. Well, let me show you another one that you'll probably like even more, and that is this vector. Oh, I do have a sort. Cool. So this vector template, and what's cool about this one is that unlike an array, see, you can just build this vector. Now this vector, we have to tell it what type it's going to take. So standard vector of type int a. And then because it's a vector, we have all kinds of cool things we can do with it. Let's look back here on the containers, and we'll find this vector. It is one of my favorite data structures in C++ because it's so powerful and flexible. And so you can see it has a number of neat things. It has an assignment operator, so we can assign content to it. It has ways of finding the size and resizing it and so on, which we don't actually, is easier to do. It has the operator square braces, so we can read elements and assign elements out of it just like it was a standard array. We have special methods that return the first and the last thing. We have a really neat idea called iterators, and we have these really wonderful things that allow us to insert an element into a spot, push to the back, so throw something to the back of the thing, pop something off of the back of it. I don't think there's another delete here, which is interesting. We can swap two things. There's just a built-in method for swapping. Yay. And so on. So these are pretty neat. Let's look at one. You want to see one? Sure, I've got you covered. So let's say here I've got a standard vector of integers, A. Okay, and then I can invoke its pushback method to put a 1 in there, and a 2, and a 3. Now find me element number 2, that's going to be 2. I can remove an element, pop back, I'll pull the last thing off of it. So this is acting basically like actually it's acting like what we're going to call later a stack, where we can add elements only to the back and remove elements from the back, but we can also put things other places. Here's a really neat thing. We can use the insert to add an element to an arbitrary spot. So there are key positions, right? Insert at a.end 300. So that means put it at the end. If I want to put something in the second place, we could do a.begin plus 1. Oh, that's neat. I'm going to put a 4 in there, for whatever reason. Okay. And then here's the really cool thing, right? When we are trying to insert things in an array, well, you can't really because the size is predetermined, right? But when you insert things into a vector, it magically moves everything. It's not magic at all. There's a couple of techniques that it's using. We'll try to get into those. And there's two main ways it's done: an array list or a linked list. We'll do linked lists later for sure, and I'll mention array lists. But it's doing some sort of magic. It's got that encapsulated, hidden from you, so you don't have to worry about the details. And that's pretty great. And then the other really fun thing I like about these container classes is that you can iterate through them in a much prettier way than a standard for loop. So you can say iterator a.begin. So here's where you make a thing called an iterator. It's just a tool for looking at all the elements. And you can say, hey, this thing begins at a.begin, go to a.end, and increment the iterator. But what's so beautiful about the iterator is that becomes a pointer to the thing in the list. So it's a much easier, more elegant way to iterate through this container. Oh, it's super nice. And then you just print out, you know, that thing. Now it's a pointer, so you need to remember to dereference it. And then you'll see the end. Let's take a look at that and see if it works. Okay. Okay, G++ vec demo / a.out. Okay. Yay! So it's doing what we wanted to do. It's pushing stuff in and taking stuff out, and it's really super handy. Now, my question, of course, is what if I wanted to make a vector of a particular type of class, right? Okay, I know what you're thinking. Some of you are working on a heap of students. You're like, this would be so much easier if I was just doing this as a vector. Right, but I want you to do it the standard way first. Make sure you understand what's going on. Make sure you can appreciate what's happening in your final project. If you're doing it in C++ and you have something like this, you have some sort of a important list of things, I would love for you to use a vector there. But once in your life, make sure you know how to make an array on the heap, because that's an important skill. And you do need to understand how that's working exactly. Okay, does this make sense? Of course, it does beg the question, can I create a vector on the heap? Of course you can, and you probably should. So yeah, it's pretty cool. All right, let's take a look at that sort. Now, I didn't test this one, so we'll see. Okay, man. So this is really cool too. And actually, this one, if you do want to use this for heap for students, I think I'd be okay with that. But it may not be as easy as you think. I don't know. We'll see. So here's an array. So I have an array of integers, 1, 4, 2, 8, 5, 7. Good. They're not in order. Now, one of the things I've always thought was weird about arrays in C and C++ is there is a size of method, but that returns the size of a structure in bytes. Well, lovely, but that's not really what I want to know. I want to know how many elements it has. And this is a traditional array. It's storing the data in contiguous memory with pointers. You see why that pointer stuff was so important, right? So now I want to know the size of this array, how many elements are in it. Now, of course, I could look at it, but sometimes you don't know that. So size of array divided by the size of int will tell me how many elements are in the array. Okay, and I'm going to have a print array function that'll just print the array out. And then I'm going to try this random shuffle. And for the random shuffle, it says, well, you can take it and you can randomly shuffle these in any order you want, but it needs to know the beginning element and the last element. And it's looking for a pointer to the beginning element and a pointer to the ending element. Well, that's okay. The array name itself is the pointer to the beginning element, and a plus n with pointer arithmetic gives us a pointer to the last element. Does that make sense? That makes sense. You got it? Got it. All right, this is good stuff. All right, so now we'll do, we'll print that randomized array. hopefully it'll be random. And then we'll run this standard sort, which again needs to know the pointer to the first element and the pointer to the last element. And we'll print that and see how it works. The print array is the only real custom function I wrote here, and just to make it convenient so we can see all of the elements. Okay, so should we run this? I actually didn't test it. I'm living a little bit dangerously. Okay, maybe it'll crash. Okay, so G++ sort.cpp. All right, /a.out, a.lout. Okay, there's the original. That is sorted. That is randomized, and that is sorted. Oh my goodness, that's easy. Yes. Okay, so there's an obvious question, right? What if I want to sort students, right? Because the students are classes, they're complicated. Can I sort students in the same way that I can sort integers? Could I just make an array of some other class and sort that array? And the answer is yes, you can, but just like our custom template, you have to be a little bit thoughtful about it. Because remember back when we made that custom add things template, it was presuming that we knew that those two things that we were going to add, or the three things we were going to add, would actually have the plus operator overloaded. And when you think about sorting, you've already done a sort, right? We did that on purpose. When you think about a sorting algorithm, what you need to know is if one thing is larger than another. Yeah? So typically, in order for the sort algorithm to work, you can take any type as a data member, but it has to have the, I believe it's the greater than operator overloaded, so that it knows, how can I tell if one thing is bigger or smaller than another thing? Does that make sense? That makes sense. Now we're going to see later, probably after we do some Java, some nice ways to describe a class and to categorize a class so that we can be confident it has that behavior. We don't have that yet, and that's fine. The main thing I want you to know at this point is, first of all, to understand that you could build a template if you want to. The second, and maybe far more important thing, is that as you're starting to do serious coding in C++, you'd be crazy not to utilize some of the really incredible built-in templates that we have for doing more advanced things, like having more advanced containers and having more advanced sorting and other kinds of algorithms. There's some nice searches and there's some neat things. Okay, does that make sense? All right, great. See you next time.